Good morning, children. How are you? The previous class we discussed about the structure of the atom. The structure of the atom is the basis of chemistry. So, whenever you are going to study chemistry or any branches of chemistry, first of all, you know the structure of atom. In the structure of atom, the more important things you have to remember is the three fundamental particles present in the atom. Three fundamental particles present in the atom. What are the three fundamental particles present in the atom? They are protons, electrons, and neutrons. Protons, electrons and neutrons. We get a clear idea about protons, electrons and neutrons. The name of the scientists who discovered the particles, their position in the atom, their charge, as well as their mass. Then the next important thing is, the most important thing is the electron configuration. What do you mean by electron configuration? Electron configuration means the arrangement of electrons in different shells around the nucleus. The arrangement of electrons in different shells around the nucleus. We have learned that the center of an atom is called nucleus. This is nucleus. The nucleus contains protons and neutrons. The nucleus contains protons and neutrons. So, protons and neutrons are also called nucleons. Since they are found in nucleus, they are also called nucleons. Protons and neutrons. The electrons are revolving around the nucleus in definite paths. These paths are also called shells. The first shell is named as K. The second shell is named as L. The third shell is named as M. The fourth shell is named as N. So, you have to study it very well. The center of the atom, this is nucleus. Nucleus contains protons and neutrons. Since proton is situated in the nucleus, the charge of the nucleus is also positive. The charge of the nucleus is also positive. Why? Because it contains protons. And the electrons are revolving around the nucleus in definite paths. The electrons are always revolving around the nucleus in definite paths. These paths are called shells. What are the different shells? The first shell, which is closer to the nucleus, is named as K shell. The second shell is named as L. The third shell is named as M, and the fourth shell is named as N. This is equal. This is shell number. The previous class I explained to you that, like in your attendance book in your class, you have your attendance book, your number and your name. Both are same. Instead of calling your name, your number also must use several times. This is shell number. Shell number 1, K. Shell number 2, N. Shell number 3, M. Shell number 4, N. Then the third main thing is the maximum number of electrons. The maximum number of electrons that accommodate in each shell. The K shell, there are only 2 seats. Only 2 electrons can accommodate in K shell. This is the lowest energy level. The lowest energy level is K. The second shell, there may be contain 8 electrons. Maximum number, there are maximum 8 Cs. Only 8 electrons can accommodate. If there are the first shell 2, second shell 8. If there are 3 electrons in an atom, first 2 electrons enter the K shell. The third electron enter to the. If there are 10 electrons in the shell, first 2 electrons enter the K shell, then the 8 electrons enter the second shell, L shell. If there are 11 electrons, first 2 electrons enter the K, then 8 electrons in the L, then remains one more electron that goes to the M shell. In the M shell, that can accommodate the maximum 80 electrons. And the M shell, that can maximum 32. This is the maximum number of electrons that can accommodate in a shell. We can calculate or find out the number of electrons in each shell by using the formula 2n square. For example, in the K shell, shell number is 1. So you can calculate formula using 2n square. Here 2n square, instead of 2 into shell number 1 square, that is equal to 2 into 1, that is equal to 8. The second shell number 2, there were 2n square, using for 2n square, 2 into 2 square, that is equal to 2 into 4 sum 8. So, this is the most important thing. You have to learn how to write the electron configuration of atoms. For example, you have to learn 3 things: atomic number, mass number, and electron configuration. While you are writing the symbol, you have to note these 2 things. For example, sodium. The symbol of sodium is Na. Generally, here you write this is atomic number. This is not by the letter S. And here you write the mass number. It is not by the letter A. For example, sodium 1123. This 11 denotes atomic number. This 23 denotes mass number. So students, please be note here. While you are writing the symbol of sodium, left side below you write 11. Now it is not it denotes atomic number. Left side above, on the top writes 23. It's a mass number. This is while writing the symbol of the elements. This is a full symbol. Then we can get a clear idea about all. Atomic number means 11. This atomic number is 11. That means it contains number of protons. How many protons are there? Atomic number is equal to number of protons, or protons is equal to 11. It contains 11 protons, so its atomic number is 11. If number of protons is 11, the number of electrons is equal to also 11. In every atom, number of protons and number of electrons are same. Then, if we know the number of electrons, we can write the electron configuration. Electron configuration, shell, electron. What are shell? The first shell K. Total number of electrons 11. First shell contains 2 electrons. Then remains 9. Second shell is L. It contains 8. Then 8 plus 2 10. Then remains one more electron that goes to M shell. So the electron configuration of sodium is 2, 8, 1. Then by knowing the mass number is equal to atomic number. Mass number is equal to protons plus neutrons. P plus L. Mass number means P plus L. P is protons and N is neutrons. Then by deducting number of protons to 23, we get number of neutrons. For example, Mass number is equal to 23. That means protons plus neutrons is equal to 23. Here proton is 11. 11 plus neutron is equal to 23. Therefore, number of neutron is equal to 23 minus 11, that is equal to 2. So, by knowing, we can calculate all the numbers. Today, we are going to discuss about two new terms, namely isotopes. Elements having same atomic number but different mass number are called isotopes. That means some element exists in the nature, exists in the universe in more than one form. They are the elements same because they contain the same number of protons. It is the number of protons. It is the number of protons who decides which is the deciding factor which element it becomes. If the number of protons is 1, it is hydrogen. If the number of protons is 2, it is helium. If the number of protons is 3, it is lithium. If the number of protons is 4, it is beryllium. If the number of protons is 5, it is boron. So, proton is a deciding factor. Number of protons is a deciding factor which element it becomes. So, in the case of hydrogen, we all know there are some special properties regarding hydrogen. What are the special properties? It is the smallest element, it is lighter than air, it is the only atomic number is 1, that means it contains 1 proton. Then the other thing is, it is only element which the nucleus does not contain any neutron. It is only element which does not contain neutrons. The element which has no neutrons is hydrogen only. So, in this universe, hydrogen can be found in 3 states. For example, one is protein. Protein contains only 1 proton and 1 electron. Then another hydrogen, it contains nucleus 1 proton and 1 neutron. Electron same. Then can see another hydrogen, its nucleus contains 1 proton and 2 neutron. This is protium. This is protium. This is deuterium. This is tritium. These are the isotopes of hydrogen. These are the isotopes of hydrogen. Protium, deuterium, tritium. Please look here, what are the differences between these? All of them, the 3 of them contains 1 proton, 1 proton and 1 proton. Number of protons remains same. Number of protons remains same atomic number. But in this, in ordinary hydrogen, there is no neutron. In deuterium, there is 1 neutron. In tritium, there are 2 neutrons. So, here the mass number is 1. Mass number is equal to proton plus neutron. If there are no proton, neutron, so 1. Here the mass number is 2. Here mass number is 3. So, this is the dimension. Same atomic number, but different mass number. This can be represented by the symbol protein and we are represented by symbol H. Atomic number 1, mass number 1. Deuterium, atomic number 1, mass number 2. Tritium, atomic number 1, mass number 3. Protium, deuterium, tritium. So you have get a clear idea about protium, the isotopes. These isotopes have a wide variety of usage in medicine. In medicine, for the treatment of cancer, the isotope of cobalt is used. For the treatment of goiter, the disease goiter, an isotope of iodine is used. In the nuclear reactors, an isotope of uranium is used. So, out of these three, you have to remember some uses of isotopes. What are the uses of isotopes? Common uses, or which isotope is used in nuclear reactor? In nuclear reactor, uranium is used. Uranium. The element uranium, an isotope of uranium is used in nuclear reactor. Which is used in the treatment of cancer? Cobalt-60 is used in the treatment of cancer. Then the disease goiter, the iodine is used. So you have very well. So first of all, you have to learn the definition. What is isotope? What is isotope? What are the isotopes of hydrogen? How they differ each other? We can there is a carbon, chlorine, etc. also shows different isotopes. What is an isotope? Elements having same atomic number. Atomic number is not written on the left side, lower, left side. Same atomic number but different mass number is known as isotopes. What are the three isotopes of hydrogen? Protium, deuterium, tritium. How they differ each other? In protium, there is only one proton. In deuterium, therefore, mass number is 1. Deuterium, there is one proton and neutron. And tritium, there is one proton and 2 neutrons. What are the isotopes? Carbon atomic number 12. Carbon 12, 13. Carbon 12, 14. Carbon 12. These are the three isotopes of carbon. Their atomic number remains 12. Atomic number is carbon 6. The atomic number of carbon is 6. In this isotope, 6 protons and 6 neutrons. In this isotope, there are 6 protons and 7 neutrons. In this isotope, there are 6 protons and 8 neutrons. Their atomic number remains same, mass number differs. Similarly, in the case of chlorine, also shows 11, 35, 11, 17, 35, 17, 37. These are the two isotopes of chlorine. So, you must remember this thing: define isotope, define isotope, the three isotopes of, especially the three isotopes of hydrogen, isotopes of carbon, isotopes of chlorine, then the uses of isotope. The isotope, which isotope is used in the treatment of cancer? Cobalt, COBALT. Cobalt is used in the treatment of cancer. Cobalt is used in the treatment of cancer. Iodine, the iodine is used in the treatment of goiter disease. And which isotope is used in the nuclear reactors? Uranium. Then you have to do another term, isobars. The element having same mass number and different atomic numbers are called isobars. Here, same atomic number, different mass number. Isobars, same mass number, different atomic number. In exam, you may ask the question, distinguish between isotopes and isobars. Distinguish between isotopes and isobars. What's the difference between isotopes? Elements having same atomic number but different mass number are called isotopes. What is isobars? Elements having same mass number but different atomic number. Here the two part here in the case of isotopes there is different mass numbers. In the case of isobar there is different atomic numbers. For example, two isobars are argon and potassium. Argon atomic number 18, mass number 40. In the case of potassium, atomic number 19, mass number 40. Can you look? Argon and potassium, they are same mass number 40, but their atomic number equal. Argon, the atomic number of argon is 18 and the potassium is 9. You have to get a clear idea. You know that the left side below we write the atomic number. Above, top, bottom right atomic number, top we write mass number. Same mass number. Different. That is isobars. So you have to understand the difference between isotopes and the isobars, how they differentiate. So let us conclude this chapter. This is the two important chapters in your class are the atoms and molecules and the structure of atom. You have to learn it very clearly. Then the coming the higher classes. This is the basis. Chemistry is the branch of science which deals with elements, compounds and chemistry. Elements, compounds and chemical reactions. So basis is studying about elements, studying the properties of element, we have a clear idea about elements. All the properties of the elements depends upon its atoms. Atoms are the genes, the deciding factor, the property deciding factor. Now on a clear look, the property of the atoms depends upon the electron configuration, the number of three particles, protons, electrons and neutrons. So you have to understand these things. Brief notes should be sent you today itself. The coming month, February second week, or you have an annual examination. First, you have to detailed study about these mainly these two chapters. What are these? Atoms and molecules and the structure of atom. At the end of the textbook, there are some questions. You have to read the notes and refer the answer. Try to answer the question. Any doubt, ask me. For example, the first three questions are you can directly compare the properties of electrons, protons and neutrons. The given note, the notes will send you WhatsApp today itself. Then it may be given in the chart. Then what are the limitations of J.J. Thomson's model? What are the limitations of Rutherford's model? The limitations are the first two paragraphs. You can clearly the drawbacks of Rutherford model and the drawbacks of J.J. Thomson model as clearly given in the textbook. So you have to Thomson's proposed that. Then although Thomson's model explained that atoms are electrically neutral, the results experiment carried by the other scientists could not explain this model as we see will though. So these drawbacks can be you have to write one or two sentences, not the detailed. The drawbacks are clearly given. Then the next question, describe the Bohr model. Now we are studying, this is the Bohr model. What is this one? The center of an atom is nucleus and the electrons are revolving around the nucleus in different shells, K shell, L shell, M shell. And the maximum number of electrons that occur in shell is 2, 8, 18 and 32. There are three rules regarding how to write the electron current, how to fill the electrons. The three rules are: first, the maximum number of electrons, quantities, find out using the formula 2n square. Second thing is The outer shell cannot accommodate more than 8 electrons. The outer shell only. Outer shell cannot. If there is the outer shell is N, that can accommodate, or the outer shell is M. M does not contain 18 electrons if it becomes the outer shell. Outer shell means contain only 1 to 8 electrons. Then the third thing is the inner shells are to be filled first, then goes to the outer shells. Electron filling takes place from K shell onwards. Compare all the proposed models of atom given in this chapter. Summarize the rules. These are the 3 rules. Define valency by taking examples of silicon and oxygen. Silicon and oxygen. Oxygen, atom number 8, electron configuration 2,6. What's the valency? Valency and valence electron. As I explained to several. Valence electron means the electrons in the outer shell. Number of electrons outer shell. This is valence electrons. Electrons outwards, this is valence. What is valency? What is valence? Valence electron is 6. What is valency? Valency is the combining capacity of the electron. That means the number of electrons gained or lost to attain stability. This atom requires 2 more electrons to attain stability. An atom attains stability when it has 8 electrons outermost shell. So its valence is 2. But in the case of silicon, atomic number 14, electron configuration 284. Its valence electron is 4, valency is also 4. Why? Valence electrons means electrons in the outermost shell. Valency is number of electrons gains or lost to attain stability. Here in this atom does not gain or lose, but it share electrons. But the number of share electrons is also 4, hence its valency is also 4. Go to the next question. Explain with the examples atomic number, mass number, isotopes, isobars. Give any 2 uses of isotopes. Atomic number, mass number. We can take any element and explain it. Fluorine 1735. Atomic number 17. That means 217 protons. Mass number 35. That means number of protons 17, number of neutrons 18. How we get? Mass number is equal to protons plus neutrons. Protons 17. Then we add 18, we get 35. Therefore, number of neutrons is equal to 18. Isotopes and already discovered uses are also now I explain to you. Na positive has completely filled K shell and L shells. Sodium atom, atomic number 11, electron configuration 281. Na positive, electron configuration 280. How you clear? This is sodium atom. Atomic number common sodium. Atomic number 11. Number of protons 11. Number of electrons 11. Electron configuration K shell. K shell 8 electron. K shell 2 electron. L shell 8 electron. M shell 1 electron. It is not stable. This sodium atom is not stable. Why? It has one electron out of motion. How it can attain stability? It can attain stability when it attains 8 electrons in the outermost shell. There are two choices for an atom to attain stability. What are the two choices? Either it will lose one electron, then it gets stable. It will lose one electron, or it receives 7 electrons. What is easy? In the case of sodium, losing one electron is very easy. Gaining 7 electrons is not that easy. So, while taking part in chemical reaction, it loses one electron. If one electron is lost, number of protons remains same. So, an electron, our negative charge is gone, it gets an additional positive charge. That means, in the case of sodium atom, protons is equal to 11, electrons is equal to 11. In the case of sodium ion, this is charge, negative charge. In the case of sodium ion, proton is equal to 11, electron is equal to 10. Where does one go? It loses one electron. So, an additional positive charge is balanced. It's not can cancel each other. So, it can. This is the difference. If bromine atom is available in the form of, say, two isotopes, bromine 3579 and 3581, calculate the average atomic mass. Almost all the atomic masses of the elements are, there are points how, for example, the atomic weight of hydrogen, the atomic weight of hydrogen is 1.008 by hydrogen has 3 isotopes: hydrogen, protium, deuterium. So, by taking the average of these 3 isotopes and their present in the orthogonal we calculate. By calculating, we can find out this point figure. The average atomic mass of a sample of an element X is 16.2 U. What are the percentage of isotopes? Because these models are given in your textbook, you do it. If Z is 3, what would be the valence of the element? Also name the element. If Z is 3, Z means atomic number. For example, 11 A, atomic number is 3. Then the question, the valence of the element. Proton is equal to 3, electron is equal to 3, electron configuration is equal to 1. Its valence electron is equal to 1. Number of electrons in the outermost shell. Valence is also 1. Composition of a nuclei of two isoatoms with X and Y are given as under. Protons 6, 6. Neutrons protons 6, 8. Give the mass numbers X and Y. What is the relation between two species? Two elements X and Y. What is the atomic number of X? Atomic number means number of protons. 6. Here also it's 6. What is the in the left top we write mass number. Here 6 protons are 6 neutrons. So mass number is equal to 12. Here mass number is equal to 40. Give the mass numbers. Then what is the relation between these two? They are same atomic number, different mass number. They are isotopes. For the following statements, write it true or false. J.J. Those proposed that nucleus is an atom containing only nucleus. That is, nucleus of an atom contains only nucleons. That's correct. Nucleus contains nucleons. A neutron is formed by an electron and a proton combining each other, therefore it is neutral. That is false. The mass of an electron is 1 by 2000 times of that proton. That is true. An isotope of iodine is used for making tincture iodine, which is used as a medicine. False. Isotope of iodine is used in the treatment of goiter. Tincture iodine is produced by dissolving iodine in alcohol. We put tick against correct choice and cross against wrong choice in the questions 16, 15, 16, 17. Rutherford's alpha particles scattering experiment was responsible for the discovery of atomic nucleus. Atomic nucleus, correct. Isotope of an element have different number of neutrons. There are mass number difference. Atomic number remains the same. Number of Barr's electrons in chlorine. Barr's electrons is equal to in Cl negative ion. Atomic number of chlorine is 17. Atomic number of chlorine is 17. Then electron configuration is 287. In the case of chlorine atom, the valence of chlorine is 17. Electron configuration 287. Chlorine atom 17. Here you please note the question, there is Cl negative. That means one more electron is added to 288. In the case of here, valence electron is 8. Please note the question. Not chlorine is given, Cl negative. Chloride ion is given. Chloride ion means an additional electron is received. So you have to first you read the test book, first you observe the YouTube class, then read the test book, then read the notes I given to you through WhatsApp, then try to answer the questions. Okay. Thank you all. You read well, study well, write the exam well. The next year you are on the top post class, top post standard in the school. Wish you all success. Thank you.